In this lecture, we're going to discuss the first part of Module 2 for the subject Bridge Engineering. In this lecture, we're going to discuss the different design philosophies that we apply in bridge design. The general requirements for bridge design would follow the AASHTO specifications, in which it requires highway bridges to be designed for the following factors: constructability, safety, and serviceability, in which it takes also into consideration the issues of inspectability, economy, and aesthetics. All of these factors will be discussed in this lecture. The first requirement for bridge design is constructability, which refers to the ability to successfully complete construction of bridge being designed. It is a prerequisite for the bridge to start its design life by entering the stage of operation, meaning that a bridge is constructable if we are able to build the design of the bridge. Therefore, it is necessary to discuss the constructability before the general design issues. Under the new provisions that is included in the LRFD specifications, there is a need for us to identify the materials that is to be used in our bridge construction. Likewise, it is also required for us to indicate a clear and feasible method of construction. And whenever there is a need for necessary or additional strengthening or temporary bracing or support during construction of the bridge, this should also be indicated in the design specifications before the construction starts. The second requirement or objective for highway bridge design is safety. In any structure or in any design, an engineer's primary responsibility is public safety. In safety, this would now include structural survival, wherein the structure should not collapse under design event. Also, the structure should remain stable under designated emergency vehicular liability. And lastly, the structure design may be reopened to all traffic after inspection following an extreme event. An example of an extreme event would be earthquakes, typhoons, hurricanes, and others. So, in design of bridges, the specifications now given by the AASHTO would have the following purpose. It means its purpose is to, as we have said, ensure the safety such that minimum resistances would exceed the potential maximum demands or force effects due to various loads during its design life. So we are not only designing the strength of the bridge, but we also design its safety. Okay? So the specifications now, the safety and its strength would be measured in terms of the following: the strength, the stiffness, the stability of the structural system, meaning the stability of the different components of the bridge. Okay? So we have different design methods that we follow in designing bridges, like other methods that we use in designing different structures. Okay? So these design methods are also known as the philosophies of safety for bridge design. So this includes allowable stress design or ASD, as called by the AISC, which is also known as the working stress design or service load design, as called by the AASHTO. Second design method or philosophy of safety that we use for bridge design is the load factor design, or we also call this as the ultimate or the strength design. And lastly, we have the load and resistance factor design, which is now the most used design method or safety philosophy for bridge design. So this is the design method that we are going to focus and we are going to use all throughout the subject. So we have working stress design or WSD, or also known as the allowable stress design or ESD, or the service load design by Ashton. So the working stress design is limited to recognizing only some loads being variable than others. Okay? It does not recognize. So, ibig sabihin, in the working stress design, we assume that more or less all of the force or all of the loads that is experienced by the bridge would not vary from each other or will have the same effects to the bridge. Okay? It treats each load in a given load combination as equal. Okay? And the concept or basic concept in working stress design would follow that the maximum applied stress in any structural component would not exceed a certain allowable stress under normal service or working conditions. Okay? This is now based on the premise that one or more factors of safety can be established based primarily on experience and judgment that will assure safety of a bridge component over its design life. So it's more of a practical design method. Does not consider the probabilities of failure based on different load combinations. The equation for sufficiency of for working stress design would follow that the sum of the QI or of the loads should be less than or equal to the ratio of R, the resistance all over the factor of safety. Okay, so QI is the load, R is your elastic resistance, and Fs is your factor of safety. So, ganito lang kadali si working stress design. Summation lang siya ng loads and we compare it to the ratio of the resistance and the factor of safety. Kasi we are assuming that all loads are equal and non-variant. Okay? So what are the disadvantages of using the WSD? One is that resistance concepts are based on elastic behavior of the material used. Okay? It does not embody reasonable measure of strength, which is a more fundamental measure of resistance allowable stress. So safety factor is applied only to the resistance and loads are considered to be deterministic, meaning walang variation. All loads are the same. And lastly, selection of safety factor is subjective. It does not provide a measure of reliability in terms of probability of failure. So, with this, hindi masyado nang ginagamit ang working stress design as there are no variations or it does not consider variations in effects of loads and the load combination. Okay? Next, we have the load factor design or LFD, or also known as the ultimate design by older ECI code and the strength design by ECI and AASHO specifications. Okay? Basic concept of LFD is that it recognizes that the live loads, specifically vehicular loads and the wind forces, is more variable than the dead load. So in here, it considers now that there could be variances in the vehicle loading of that would pass through our bridges. Okay? The load factor design or the LFD is developed or was developed in order to overcome the disadvantages of the ESD method. So in LFD, we now multiply the different loads by factors greater than 1 and these factored loads are added together in order to produce different load combinations for the design purposes. The equation of sufficiency, or the safety criterion for load factor design, is given by the equation: the summation of the factored load is less than or equal to phi times R, wherein we have gamma as our load factor, and your Q is the load, R will be your resistance, and phi is the strength reduction factor. So the product of your gamma in Q will be your factored loads. So the disadvantages of the load factor design would be based on a probability point of view. So it means that the load factors and resistance factors were not calibrated on the basis that takes into account statistical variability of design. Okay? So next we have the load and resistance factor design, the LRFD, which is a design methodology where applicable failure and serviceability conditions are evaluated considering the uncertainties associated with the loads by using load factors, material resistances by considering resistance factors. Okay, so in here, we consider now all possibilities of combinations and effects of loads based on the materials as well. Advantages of LRFD would include the accounting for variability and uncertainty in both resistance and loads, and would achieve relatively uniform levels of safety that is different for each limit states and material type to possible extent. Okay? It would provide more rational and consistent design method for any structure, and it would be consistent with other design specifications that we use for bridge design and other structures. Limitations of LRFD would include that it is one of the most rigorous methods for developing and adjusting resistance factors so as to meet individual situations. Okay? It would require a change in the design philosophy from previous AASHTO methods, and it requires understanding of the basic concepts of probability and statistics. It requires availability of the statistical data and probabilistic design algorithms. Okay? So the safety criterion, or the efficiency equation for sufficiency that we use for LRFD is given by the equation that the sum of the products of the modifier, the load factor, and the load is less than or equal to that of phi Rn, wherein phi Rn is equal to R sub R. So this equation now gives us gamma, which is the load factor, which is statistically based multiplier applied to the force effects present on the structure. We also have your eta, which is the load modifier, which will be classified or categorized as the ductility, redundancy, and operational importance. So QI will be our force effect or the load on the structure. P is your resistance factor, which is a statistically based multiplier, which will be applied to the nominal resistance R sub n, wherein the product now of P and R sub n will be our factored resistance. So this equation now is a AASHTO LRFD equation. So for the load modifier eta, we'll have different values depending on the value of your load factor. So for maximum values of the load factor gamma, the load modifier will now be equivalent to the product of the load modifier for ductility, resistance, and operational importance. And it will be greater than or equal to 0.95. While if you're going to use the minimum value for the load factor, the load modifier now will be computed as the reciprocal of the products of the individual load modifiers for ductility, resistance, and operational importance, which will be less than or equal to 1. So the load modifier for ductility, eta sub B, is the response of structural components or connections beyond its elastic limit. So this will be characterized by the brittleness or the ductile behavior of the material. So under the strength limit state, for non-ductile materials, we have a value of eta sub D greater than or equal to 1.05. For conventional designs, we have the value equal to 1. And for components or connections that is beyond the AASHTO requirements, the value now will be greater than or equal to 0.95. While for other limit states, like your service, strength, service, fatigue, and extreme events, the value for the ductility load modifier will be equal to 1. So for the redundancy load modifier eta sub R, we know that redundancy is a significant effect or will have a significant effect to the margin or safety margin of a bridge structure. And we also know that a statistically indeterminate structure is considered redundant when more restraints are present than is required in order to satisfy the equilibrium. For strength limit state, for non-redundant members, we will be using a load modifier, eta sub R, greater than or equal to 1.05. For conventional redundancy levels, we have the redundancy load modifier equal to 1. For exceptional redundancy levels, it will have eta sub R greater than or equal to 0.95. While for other limit states, we'll now have a value of the redundancy load modifier equal to 1. For operational importance eta sub I, a bridge will be classified as operationally important when it will have the shortest path between important land uses. So this would include the residential areas, hospitals, schools, or a bridge would be operationally important if it provides access for police, fire, and rescue vehicles between the residents, businesses, and industrial plants. So for strength limit state, the load modifier eta sub I will be greater than or equal to 1.05 if the bridge is of operational importance. For typical bridges, the eta sub I will be equal to 1, and for relatively less important bridges, will have the limit at 0.95. For other limit states, the value of eta sub I will now be equal to 1. So the next requirement for bridge design would be the serviceability of a bridge. Serviceability would be defined as the ability of a bridge to serve specified functions at an acceptable level over its design life. So from the specifications, serviceability will be defined by the following parameters: durability, inspectability, maintainability, rideability, control deformation, facilitating utilities, allowance for future widening. So when we define durability, it means that the material used for our bridge or in our design should be able to withstand or resist loads or other factors that could affect the strength of the design. So in that case, in contract documents, it should be specified what materials we are going to use. And those materials should be of high quality and that it should also be able now to resist moisture content or salt attack from the different locations in which the bridge will be built. So example, yung mga bridge natin na built on that would span over bodies of water. So basically, the piers there would be subjected to moisture content because of water. So kung C yung ating obstacle, then there will be possible attack of the element ng or yung salt compound. So therefore, the materials used for that bridge should be able to withstand these effects. Okay? So next we have maintainability. It simply means that the bridge design or your bridge should be or you should be able to maintain the bridge or the maintenance should be allowed during its service life or its design life. Okay? So with that, the maintenance now of the bridge should not stop the traffic flow of the vehicle that will use our highway bridges. So ibig sabihin, from our discussion in our introduction, that bridges are key components of the transportation system. That means when the bridge fails or the bridge closes, our transportation system closes as well or fails as well. So we do not like that. So in maintaining your bridges, dapat kahit na mine-maintain natin, nagre-rehabilitate tayo, inaayos natin yung bridge ninyo, the traffic flow should still be continued or hindi man full capacity, meron pa rin yung operation ng ating traffic flow because it will be unacceptable for those users, bridge users, highway users, when transportation would stop as it would affect their livelihoods, the economy, and other factors. So next, we have rideability. So when we say rideability, maganda ba yung experience natin sa paggamit ng bridge? When we ride our cars, our vehicles, and we use the bridge, is our transportation comfortable? So the rideability would basically be relevant to the bridge deck, since the bridge deck is that component of the bridge that would provide us the surface for traveling. So therefore, our deck now should be designed in order for us to have a smooth movement of vehicle traffic. Okay? So aside from the smooth flow of traffic, maganda yung experience nung dumadaan sa bridge, he or she also feels safe when using our bridge surface or when riding through our bridge. So next we have facilitating utility. So for this, in the construction of our bridges and as well in the design, we have to take into consideration our bridge as being able to support and maintain conveyance for utilities. Okay, so meaning, dapat yung bridge natin is able now to provide spaces for this kind of utilities such as your utility pipes. So when you say utilities, this could include pipes for water flow, electrical wirings, communications, and others. Then next, we have allowance for future widening. So in here, in our design, we have to take into consideration that there would be a probability of increase in traffic flow. So when there's an increase of traffic flow, it means there is a need for us to increase as well our carriage width for our bridges. Okay, so with this, in the design, the capacity of your exterior beams should not be lesser compared to that of the interior beams unless if will not or we are certain that widening is inconceivable or is impossible for our bridge site. Okay? So in widening now, we also have to consider our design for the substructure for widening as well. So dapat, pag nag-widen tayo, yung substructure natin should also be able to carry that future widening or that future load. Okay? So again, in our design, future widening is affected by the possible increase of traffic flow of transportation factors. Okay? And lastly, we have control deformation. So for deformation, this would basically be in terms of the deflection of your bridges. So in your design, we should avoid the structural deformations. So when there would be a large deflection on the bridges, so what would happen? So basically, pag dumaan ka doon sa bridge ninyo, there you will be experiencing some vibrations. So when you feel that deflection, that vibration while passing through your bridge, so what will you feel? So basically, you'll feel uncomfortable, you'll feel unsafe. So we want to avoid that, and we avoid that by controlling the deformation of our bridges in our design. So there is no specific deflection limit that is given by the AASHTO, but there are recommended deflection limits based on the material that we use on our design, specifically for steel, aluminum, and concrete structures. So in our bridge design, we have to also consider the issue of inspectability. So when we say inspectability, the bridge should be uh, open to inspections, and that would usually happen at specific times, like after extreme events, like storms, like earthquakes. Okay? So in inspectability, we do this in order to be assured that we have the bridge was able to withstand those loads or extreme loads. And as well, we're going to check or inspect if the bridge is able to cope up with the continuous use of the vehicles. Okay? So in inspectability, we should be considering also that we can permit inspectors all the view of the parts of the structures that is required for inspection and for maintenance. Specifically, yung mga structural important components. So, AASHTO specifications now also requires inspection ladders, walkways, catwalks, and covered access holes and lightings so as to permit these inspections. Pero kung hindi kaya na maibigay ito, then there are other ways to inspect the bridge itself. So, when practical, these specifications also, the AASHTO, would require access to permit manual or visual inspection of the components, such as headroom in the box sections for box cell type components of the bridge. Okay, so in here we have to basically sa inspectability, ang gusto lang natin is dapat kaya nating ma-inspect, makita, ma-check yung bridge in random times and during or after extreme events. So we should be able to check the conditions of the bridge. So we should have access. So we should provide access, and if it's not possible, then there should be some ways that we could be able to see the parts that is structurally important and significant into maintenance. So next we have economy. So the economic consideration is required at every stage and step of bridge design. So ang pera, ang budget is always an important factor in designing and in constructing, building your bridges. Okay? So from the start of our preliminary design, we have to take into account the budget for the location, the dimensions of the members, and the amount of reinforcement for your concrete components. So, yung location, yung location natin, mahal yung lupa doon. So, you have to consider those in your design. So, hindi lang dapat matibay yung ating design, dapat economic-wise din siya. Okay? So, cost saving is always a significant factor when it comes to designing bridges, designing structure. So, hindi lang safe, dapat tipid din. Hindi tipid at so titipirin mo pero hindi maganda yung design, mag-feel. So, hindi pwedeng ganon. So, they should come hand in hand. Safe design and economic design. Okay? So next, we also have to take into consideration in our design the aesthetics of the bridge. Okay? So since bridges would more likely be of significant dimensions, malalaki yung mga bridges, mahahaba yung bridges. So basically, it will become a part, integral part of the environment or of the landscape of the surrounding after construction. So some of the bridges built in different locations have become a landmark of that location. So because of that, they became landmarks because of their aesthetics on how they contribute to the view or to the look of that area. So as design engineers, we should be conscious about the impact of the bridge on our environment. So under aesthetics, we now apply the qualities of design which are intangible and would be perceived qualities as would arise from the relationships of the different design elements. So the properties of aesthetics or aesthetic qualities that we have to consider in design of bridges would be the proportion, the rhythm, order, harmony, balance, contrast, scale, and unity, wherein all of these properties are basic elements of design compositions that are most likely common to all fine arts and architecture design. So for the serviceability of bridges, accommodating for utilities or facilitating utilities for bridges, So we have to consider that the bridge would be able to provide access or good space for our utility pipes for, let's say, water, drainage, sewage, and others. So during inspections for inspectability, so we should provide accessibility to our bridge. So kung hindi pwedeng ma-access yung ating bridge for inspection, one common way of inspecting is through the use of buckets. So kung walang ladder going down to this part, then we could use your ladders. So dito, inspectability, walang na-provide na access para sa inspection. So, nasa gilid lang sila. Okay? So, aside from this one, sidewalks would also be a great access for inspections of the bridge. Okay? So, some bridges would have walkways for pedestrians and some walkways would have a separate walkway for inspections. So, some bridges would have doors at the bottom of some of their piers, wherein that door now would have ladders that would lead to some of the portions of the bridges for inspection. Okay? So, yung iba, naglalagay ng ladder dito, tapos merong walkway dito sa ilalim to inspect now this utility pipes, for example. So, in terms of aesthetics, so this bridge now complements the natural green scenery of the environment. So, the red color complements the green and blue scenery of the mountains and the water. Okay? So, in this bridge, this gives us now a nice view of the surroundings. So, even if you're going to look the height of or the depth of the girders is different at each pier, pero hindi siya masyadong nahahalata because the slant or the diagonal, the slope of the diagonals are the same. They are uniform. So, hindi siya masakit sa mata tignan. So, this is another bridge that has become a landmark or a part of the area. So, it demonstrates order and rhythm on the aesthetic part of the bridge design. So, it goes well with the presence of the creek here. Okay? So, hindi siya nakakasira doon sa view ng creek, doon sa flow ng creek. So, in here, we have now uniformity. So, kahit magkakaiba yung sizes nung ating piers, it still looks good as the shape of the piers looks similar. They all have arcs in between. Okay, so uniformity. So next, this would now be a bridge, a very big bridge, but when you look at it, it's not that big at the picture since when we are going to look at the abutment here, it's large compared to that of the pier dito sa gitna. So it gives a slender appearance of the bridge. Okay? So next we have contrast. So dark yung ating surroundings. And then, the color of the arc brings out the shape of the arc bridge, which is in contrast to the given surroundings. So this one gives us balance. So you have two bridges, okay? And they would be perfectly balanced in composition. As you can see, they both have the same design. Okay? So hindi siya magandang tingnan kung yung isa, ibang design, tapos yung katabi niya, iba din yung design. So we have to take into consideration those. And lastly, we have this bridge. So the arc of the bridge gives a good impression on the valley of this location. Okay?